Alright, right now we're going to start on the topic of the extreme value theorem. It means that we have a continuous function on a closed bounded interval. We call it f from a to b to the real axis. It attains both a minimum and maximum value. Attains both min and max. Alright, this is what we call the extreme value theorem. There are extreme values attained by certain function. The function has to satisfy a certain type of domain, which is the closed bounded interval. I'm gonna just mark it right here so you'll remember. It has to be a closed bounded interval. And a remark right here is that the image of the continuous function on a closed bounded interval is bounded above. And that is, there is the number m such that any f of x is smaller or equals to m for all of the x in this range of a to b. And if you want to draw a graph, I would like to show it right here. So if we have a closed bounded interval from a to b, there is the certain function right here. You'll see that we must have a minimum either right here or a local minimum right here, right? In this case, I'm just gonna say a global minimum because we already make the range or the domain very finite from a to b, right? So if it is an infinite function, probably we'll consider more about a local minimum and local maximum. And in this case, we just say it globally because just like what I said, the domain are very shrinked, and also the maximum is going to be right here, right? Because that is the highest place visually you can see it. So any function that you draw, as long as in the closed bounded interval, we'll see that it has minimum and maximum. And sometimes, probably when you draw a sine or cosine function, there are going to be a multiple maximum at the same height. They're maximum together, or multiple minimum. It might happen as well, but it doesn't go contradict with this idea that it attains both minimum and maximum because it's going to be a plural type of maximum and minimum. So. Alright, in the same video, I'm going to cover one more theorem because they go hand in hand with extreme value theorem. We call it the intermediate value theorem, and hopefully you already heard about it in your previous calculus class. This will just be a quick review of what you have learned. Intermediate value theorem. And what does it mean by IVT? If we suppose that there's a function f, suppose f. Again, it take the closed bounded interval AB and going to be output into the real domain. It's going to be continuous. And if we let a number that's strictly between f of A and f of B, let there's some C such that it's strictly between f of A and f of B. Or, f of A and f of B, they can be either the first one is smaller than the second one or the second one is smaller than the first one. So, we don't know about it, so I just write it as either or sentences right here. Alright, they're straightforward. If this is happening, then we'll know the following statement is true. Then there's a point x, 0, that's in the interval AB, in the open interval AB, at which f of x is going to be equals to c. And what is this theorem saying? It's saying that, alright, let's draw a graph first. We have a graph with the x-axis as the real axis, and we chose 2 points right here. We chose it to be a and b, right? And they both corresponding to a certain value of function f. We say a function f is f of a right here and f of b right here. So this is what we have, the 2 points on a function in this plane. If this function is continuous, this is how we assumed, so we just need to connect 2 of them together in some arbitrary way. And we know that if we choose a certain value right here, let's say it's c, right? Such that c is strictly in between f of a and f of b. So c has the height in this level. And we know that there must be a point called f of xo that's going to be equals to c. And in this case, we see it's right here. because the intersection of the height c and the function is right here, so that we know that at this point, the corresponding x value is going to be equals to c. Which means that this, and also this x value has to be in between a and b. Which means that as long as we find a certain value as the output that's strictly in between f of a and f of b, and we're looking at the input, it must be strictly in between a and b. And this is what we call the intermediate value theorem. When we look at it in a graph, it's very straightforward, right? Even if f of a is, for example, greater than f of b, it also holding true. This function is just going to be looking like kind of like decreasing function if there is no fluctuation in the middle.